Section 2.3, Example 7. At a used car lot, 7 different car models are to be parked close to the street for easy viewing. The 3 red cars must be parked so that there is a red car at each end and the third red car is exactly in the middle. How many ways can the 7 cars be parked? We have 7 different positions. So I have 1, 2, 3, 4, 5, 6, 7. We want a red car at each end, and we want a red car exactly in the middle. There are 3 red cars. So of those 3 red cars, I want to pick one to place in the front. There are 3 to choose from. Once that red car is positioned there are now 2 remaining red cars that I can choose from to place at the other end of the row. There's a red car in the front, red car in the back. There's 3, so that means there's now 1 remaining red car that would fill in the middle. There are 7 cars in total. We've already placed 3, so that means there's 4 remaining different cars. And now we're just going to fill in the rest. There are 4 choices. Once that car is parked, there is then 3 remaining cars to be filled, and 2 and 1. And again, using our fundamental counting principle, we multiply all of those total ways, or to find the total number of ways, and that gives us 144. We can also think about this question in permutation notation. We have permutation because the order of the cars does matter. There are 3 red cars, and we are going to place all 3 red cars in 3 different positions. We're going to multiply that by the number of ways to arrange the 4 other cars, and we're arranging all 4, so 4p4. 3p3 is 3 factorial, 4p4 is 4 factorial, and when we multiply that out, we still end up with the same answer of 144. There is a part B, so an extension to this question. This one says the 3 red cars must be parked side by side. How many ways can the 7 cars be parked? So we are going to, consider those 3 red cars as if they are distinct red cars. So red 1, red 2, and red 3. They have to be together. There are 4 other cars that need to be arranged. So in total, there are 5 different objects that we are asked to arrange. And there are 5 factorial ways to do so. Within this group of 3 cars, though, there are 3 factorial ways to arrange those 3 red cars within that group of 3. So our total number of ways is 3 factorial multiplied by 5 factorial, and that gives us 720. Again, using permutation notation, this is like we are arranging our first 3 cars, arranging all 3 cars, 3p3, multiplied by, then we have 5 objects, so that one group of 3 plus 4 other cars, there are 5 objects, so 5p5, and again, that will still give us 720.